Good morning, ladies and gentlemen, and welcome to this presentation. As you can see on the title slide, and as you already know, today is August the 13th. Does anyone over 60 remember the significance of August 13, 1961? That's the day the Berlin Wall went up. Yeah, and that's a date like that anyone who was born in Germany, like I was, will remember the same way as everyone in the United States remembers where they were when Kennedy was shot in Dallas. Now, if you do a little bit more history on that one, that was 56 years ago. When did the wall come down? 28 years ago. So it stayed in place for 28 years, and then it has been down now for 28 years. And we all thought that the bad ideas of communism and socialism were done with the fall of the wall and the fall of the Iron Curtain. And then, last year, we had a self-avowed socialist running for a major party presidential candidate in this country. As one of the main characters in the show The Big Bang, Penny likes to say, "Holy crap on a cracker." So, we are here because we are all basically undertakers of bad ideas. And since we're in New Orleans, maybe we're even happy undertakers in the tradition of a traditional New Orleans funeral. So let me see if I can help as an undertaker of some bad ideas regarding radioactive matters. And as you can see down there in the subtitle, we're going to try to distinguish disinformatsiya, a Russian word for disinformation, from real disasters. And that's, after all, what we are all about, real disasters and how to deal with them. And I dedicate this presentation to the memory of Gerald Looney, who wrote probably the best paper, very short, 2-3 pages, on radiation hormesis and the radiological imperative up there on the top. And it starts with the same words as the Bible, in the beginning. And if you have never read that paper, look it up on the internet, because it explains radioactivity, natural background, hormesis, LNT, ALARA, kinds of things that we'll get into more clearly than I can talk about in probably 5 hours. And of course, there are other people on whose shoulders I stand, people who have presented here before, whether they be Bernie Cohen or Myron Polycove or Jerry Cutler or Ed Calabrese and those people. So don't assume that anything I tell you is original. And one point that Dr. Looney made in his paper is that when the Earth started, it was a heck of a lot more radioactive than it is today. As a matter of fact, all uranium is depleted uranium, because it started with the planet there when it was still more or less a ball of magma. And what we have today, after one half-life of uranium-238, we have roughly half of the radioactivity from uranium left that was there at the beginning 4.6 billion years ago. So that means that the planet, the universe, was more radioactive in the past than it is today. That means all life evolved during higher natural background than it is today, which puts a lie to the idea that all additional radioactive background that we might get from human activities is dangerous to life or human beings. It's a totally idiotic idea based on this simple picture. Now, idiotic ideas have been around through human history. And one of the worst was the witch hunt craze that roughly lasted from 1450 to 1750. And of course, in Europe, it killed thousands of witches, and this one is from a Russian edition of National Geographic. It never showed up in the English edition, by the way, this article. But it showed what a scientist or an expert caught in a rut can accomplish if he just doesn't look left or right. These were the risk analysts of the Middle Ages and the beginning of the modern age that said, we have no idea and we cannot guarantee that witchcraft and witches exist or that they are a danger, but let us please apply the precautionary principle just in case. Let's kill a few thousand of them so that we stay safe. And that's the same approach that we have today. We haven't really changed that much since those days. And of course, this organization has done quite a bit in the past to talk about real risks versus fake risks, but we are always faced with statements such as the one on top there that's really silly. Anytime somebody wants to really emphasize that something is bad, they always throw in the word radioactive. As a matter of fact, sorry to say that, last night's speaker did that when he said the toxic and radioactive mess of these miners in Congo that mine this stuff. Toxic is enough. The radioactivity doesn't matter that these people are exposed to. And then credits to Willie here, who in 2012, talked about EPA rules and made the same point, that actually if we are going after fake risks and spend money on mitigating those fake risks, then we don't have that money to mitigate real risks, and we actually murder people. Let's just not say kill, but murder. Now, why am I up here and talking about this subject? I'm a geologist by trade. I'm retired now, but I worked for 23 years for a radioactive waste repository, and as a result, I got involved in nuclear matters as they affect especially geology and mining. And of course, geologists have to train in basically the whole spectrum of the natural sciences. They have to have a little bit knowledge of geography, of biology, of engineering, of this and that and the other. So we are actually quite qualified to be broad spectrum natural scientists. So that's why I'm talking about this subject here. Now, last year in Omaha, we had a presentation by Dr. Yuri Maltsev, originally from Russia, and he talked about nuclear and other government-made disasters. And as far as the economic part of his presentation was concerned, everything was hunky-dory. But when he got into Chernobyl, he was really veering off course. He was doing the same thing that many scientists, by the way, including geology colleagues of mine, including academic geologists, make. When the word radioactive and nuclear comes up, the brain turns off, and all they can do is spout the stuff they read in Time magazine and the New York Times. And that's the same thing that he did there, because he was talking about thousands of people had died as a result of Chernobyl. There is no evidence whatsoever for that statement. And then, of course, the Atlantic, and this is one example of radioactive disinformation. I have a few others down the road. Another one is the Atlantic Monthly magazine did publish an article 30 years or so after Chernobyl, and then they put this picture in there. This is basically a weather station display from Vladivostok. This is about 4,000 miles away from Chernobyl. This is upwind from Chernobyl, not downwind. And it shows the time of day, it shows the temperature, and then it says something rad 21. It doesn't give any units, it's absolutely meaningless. But this gets reprinted in the Atlantic Monthly under the heading Chernobyl. It's completely meaningless. It gets worse. The National Museum of Nuclear Science and History is in Albuquerque, New Mexico. It is run basically on a contract by Sandia National Lab. They have a display on the health effects of Chernobyl. You see the red underlined stuff there. In addition, in subsequent years, livestock were born deformed. Probably true. On every farm or in every farming area, some livestock gets born deformed. Did it have anything to do with Chernobyl? There's absolutely no evidence whatsoever. And this is in our National Nuclear Museum of Science and History. This is ridiculous that this nonsense is there. And then the third example, I'll have a few others later, but they're not quite that itemized. This is a report in the Smithsonian magazine about the St. Gotthard tunnel under the Alps that trains go through. And then it says, the heat inside the tunnel comes from the planet's core. Did these people ever think about the conductivity of rocks? And did they ever look into what the distribution of radioactive elements in the Earth is? That actually most radioactive elements are in the crust and some in the mantle, and that's where all the geothermal energy comes from, by the way. The final source of all geothermal energy is nuclear, and I'll expand on that a little later. But this nonsense stays in there. Of course, the Smithsonian doesn't have any peer review like Willie gets, but we get into peer review a little later too. So let's go back to Chernobyl, because after all, that is sort of one of the main themes of this talk. You have a map of the of Ukraine, not the Ukraine, but Ukraine. And of course, the Russians just occupied the Crimea, and the eastern part here is in a mess right now. But Chernobyl is up here a little bit north of Kiev, and it's where the Pripyat River empties into the Dnieper River that flows through Kiev and then into the Black Sea. And so there are the Pripyat swamps over there, which have been a problem for Napoleon and for Hitler's armies. And that's where Chernobyl is, up there. So just, you know, one of those here you are maps. Then a little bit more in detail, from the river, they built a small lake here for cooling the energy from the nuclear power plant. There's a plant. There's a town of Pripyat. And down here is something that if we have the time at the end, I'll mention briefly there as well. But this is sort of the general layout of the place. Now, when people talk about Chernobyl, it's always, oh my God, that is the worst accident, and this was typical of nuclear power, and that's why we need to be careful. So I just recently found from a German colleague, I found a description and I translated it as to what really happened at Chernobyl. And I'm not going to go into detail, I don't really have the time to do that. But a simplified analog says you have a vehicle and you floor the accelerator, the pedal gets stuck, the brakes fail at the same time, and all of this happens on a vehicle where the gas tank is mounted right on the front bumper, okay? That's sort of all the stupid stuff that had to come together in order to make Chernobyl the mess that it became. So it has nothing to do with how Western nuclear power plants operate. It has nothing to do with normal civilian nuclear power. By the way, that reactor was probably a dual-purpose reactor that was also for military purposes. And again, if we have the time at the end, I'll show you where some of the power went. The horror pictures went around the world. This is in Warsaw, where some kid gets an iodine shot. But and then these pictures got republished again at the 30-year anniversary in the Atlantic Monthly without any kind of real cause and effect discussion of, did this really have anything to do with Chernobyl? Some of you may have heard of a fellow named Zbigniew Jaworowski, who was a Polish health physicist who was actually, I think, the first person who discovered that something had gone wrong at Chernobyl from the data that he gathered near Warsaw. So while fallout from Chernobyl went over Warsaw, it didn't do any harm to people and not to children either. But then you also have these pictures from Kiev, where a child that has cancer is being depicted, and by inference, oh, that was Chernobyl. No evidence, no proof, none whatsoever. Children occasionally, unfortunately, get cancer, even die of cancer. Whether this had anything to do with Chernobyl or not, nobody knows, but there's no evidence that it had anything to do with Chernobyl. Nevertheless, these are the mental images that stick in everybody's mind. Now, what's the reality? I went to Chernobyl with two German colleagues, one a radiation protection expert, the other one a professor of engineering, in actually exactly 3 years ago, in August of 2014. These are the guides that took us through the place, and they advertised the place with, you know, the menu from the Hard Rock Cafe Chernobyl, which doesn't exist, it's just a fantasy, but then you have all these isotopes listed there on the back of his t-shirt. So these were some of the guides. And there are right now thousands of people who go through the place each year. I would say on the day that we were there were probably between 100 and 200 people there with various tour operators. It's about, as you saw on that previous map, about 100 miles or so north of Kiev. There's a control point. It looks a little bit like a control point at the old Iron Curtain. But there's really nothing. You don't go through a detector, for example. You don't have to. And you don't have to wear protective clothing. And then just to prove that I was actually there, that's yours truly standing in front of the sign for the city of Pripyat that was founded in 1970. And there in the Russian characters from the top to the bottom there, it says Chernobyl. I don't read Russian, but I just, can impress you a little bit with some of this stuff. What I took with me was one of the nuke alert radiation detectors that we haven't seen at these meetings for a while, but I bought it, I think, 4 years ago at the conference that we had in Houston. There was a fellow who sold them then. So I bought one of these detectors and I took it with me, and I'll show you some results here in the next slide. But these words down there, they were not taken from the website of the people who makes this instrument, but by somebody else who is selling it for emergency purposes. And you see that we have to be careful with that kind of information, because even there they put nonsense in there. The nuclear radiation disaster, such as Fukushima storage tank leak in Japan, first it wasn't a nuclear disaster or radiation disaster, and second, storage tanks, that was a man-made crisis afterwards. We'll see that later. And then this really odd note on that same website, due to high government sales, it's currently unavailable. I have no idea whether the government is really right now buying these in bulk, but that's the impression. So even that a good radiation detector, very, very, very good detector, but some nonsense there in the description. So, what do we have actually in the way of natural background radiation on our planet? I took this instrument that I just showed you, and I took it to several places in New Mexico, where I'm from. So in Carlsbad, we have 16, that's microrem per hour. And at Radium Springs, the highest that's right north of Las Cruces, we had 27. And I climbed on Wheeler Peak one time, but I didn't have that instrument at the time. My guess is it's probably somewhere around 30 up on the top. So that's about 13,200 and some change feet up, the highest peak in New Mexico. So you see that even in the state of New Mexico, we have a variability of about 100%. We go from 16 to maybe a little bit 32, something like that. Well, I went a couple of years ago to Poland. There's a salt mine. On the top it was 1.5. I'm sorry, on the top it was 16.3, and underground it was 1.5 because you have a lot of shielding of the overburden rock once you're down there in the salt mine. And then some higher readings here, but still not anywhere out of line here with the New Mexico readings. Casper, Wyoming, 24. We mine a lot of potash near Carlsbad, and potash is, for the most part, potassium chloride and potassium and magnesium sulfates. And when you take that, so there's K40 in there, the radioactive isotope, and if you have this in granular form as it goes into the fertilizer bags, I got a bucket full of that, and I put my detector into a Ziploc bag and then put it into that bucket, and then I covered it with potash all the way around, and that's how I got that reading there, potash packed. So when you have some potash, or you probably get a little higher reading if you try to measure banana too. Now, the really intriguing readings though are, we spent about 7 hours in the restricted zone of Chernobyl, and over that average we got 64 microrem. Don't worry about the units, because I'll always give you comparisons here. So don't worry about the units themselves. What matters is which one is larger, which one is lower. On the flight over to Europe from Houston to Amsterdam, I measured the radiation, and I measured only when we were up at flight level, okay? Not start up and then get back down. So 30 to 35,000 feet high, 320 per hour. This is what I got on the flight back when I could see Greenland out of the window, and we were at about 38,000 feet, 450. So what we got in, and that was, by the way, this measurement here was taken over the same time, but basically about 7 hours as we were in Chernobyl. So we got about 6 times more exposure on flying over there between Houston and Amsterdam than we got in Chernobyl. That should give you right now quite a good idea of how much hype there is about radioactive contamination and radiation in the natural and the man-made environment. On the left, we have the swimming pool in the town of Pripyat that operated from long before the incident in '86 and was staying in operation 12 years after. But when we went in there, it had totally decayed, and people had, ripped stuff out of there and probably used it for improving some other things. How come that this pool was still in operation 12 years after the Chernobyl accident? Well, it was used by the people who worked in the remediation of the place. And why was it shut down 12 years afterwards? Probably because it turned into a PR problem. For those people who think that radiation is dangerous, how can they still be swimming in there? They had no problem. By the way, the radiation or the radioactive fallout from the Chernobyl incident is basically, for the most part, gone. And if you want to find some sort of significant reading, you have to go to cracks in the asphalt where the stuff is still confined, where it didn't get washed away by the rain. So the guide actually showed us several cracks and said, why don't you hold your meter down there, and there you can actually get a reading that's significant. That's the only place. Again, the number doesn't really mean much by itself. This is the sarcophagus, the first one that was built. Now there's another hull on top of this thing. And we are actually downwind from where the cloud of radioactive stuff was blowing out of the reactor right after the accident. You notice right there is a memorial to the so-called liquidators that worked on encapsulating, extinguishing the flames and then encapsulating the reactor as best as they could. It's sort of odd. They put that memorial right there into the downwind plume of the reactor. If it is true that every additional increment of radiation is bad for you, and if you should keep additional radiation exposure as low as reasonably achievable, those are the standards that our regulators in NRC and DOE require. How come they actually, committed the luxury of building this thing right there in the exhaust plume? You would have put it on the other side. So they were violating definitely LARA principles. So did they believe this stuff themselves? This is another picture from the Atlantic article up there, and it shows a guide taking a picture sort of in the same place where we were before. The chimney was also on the left side of the last picture. And then it has this reading up there. It says something like 37.3. And then in the explanation it says, a guide holds a Geiger counter showing radiation levels 37 times higher than normal. Do you know of any radiation detector that gives you the times normal? No, they give you something in units, in rads or millirem or Röntgen or whatever. This is complete idiocy, okay? So even if that is true, that right here the radiation level is 37 times higher than normal, that means it's still less than half the background of a town in Iran named Ramsar. Because natural variability of radioactive background planet-wide goes over 2 to 3 orders of magnitude. So I can, with all confidence, without knowing the real numbers, say if that's 37 times higher, that's less than half the background in the highest measured natural background location on the planet. I'm stealing again from somebody else who talked to this organization before. 2006, Ed Heiserod, who wrote a really good book, What If Radiation is Actually Good for You? I recommend it to everybody, and it's still available on Amazon. And this picture shows the natural background radiation, and there you see the variability from low areas to pretty high areas. Again, the units, don't worry about micro, mini, whatever. It doesn't matter, because the comparison is what matters. And then see what happened in Chernobyl, and you see this is the evacuation line based on regulations. Does this make any sense to you? To ask the question is to answer it. Yes. Ed Heiserod again had this other slide where he showed what is obvious and well known to every nuclear and radioactive expert. That means that we get much more radiation in the Rocky Mountain states. Part of the reason for that is because we are higher up, so we have less atmosphere on top of us that stops cosmic radiation. And the other one is we are on top of the Rocky Mountains, and the Rocky Mountains consist of rocks that are more radioactive than the rocks that you have, let's say, right here in New Orleans. Whatever few rocks there are underneath us here. And so it's mostly mud and swamp, right? But you notice the correlation here, the Rocky Mountains with the high background radiation versus the cancer rate, and the Gulf Coast area with its cancer rate. And this diagram, people like Bernie Cohen and others have repeatedly talked about that a little bit higher radiation than natural is actually good for us, the hormesis concept, etc. This is a picture of one of the probably most picturesque cathedrals in Kiev, the St. Sophie Cathedral and Museum. And here's the reason why I showed you where that is, because there's a note right at the entrance, and it says participants, this says reduced rates for the entry tickets to visit this place, participants and veterans of World War II, peacekeepers, and then participants of the Chernobyl disaster liquidation, the first category. What's the reason for that? Because people just assume that they are somehow damaged. Some first responders were damaged. They actually died. But the actual number of dead from Chernobyl, actually documented, verified evidence, somewhere between 30 and 50. And I've said this before, and I'm sorry I have to repeat it. But the ordinary garden variety plane crash kills more people than Chernobyl did kill or will ever kill. But then you have the panic mongers among us. This was on the Discovery Channel, Animal Planet's, and by the way, this is from a website that actually criticized this program. Okay, that's why there's a heading. Animal Planet's bogus account of Chernobyl wildlife, fission for scare tactics, you notice the pun, and then atomic assassin, and then they showed this picture of a catfish up there, and then, nothing but mood pictures. Okay, no information value whatsoever. Okay, we talked about a fake disaster. Chernobyl was to some extent a real disaster, of course. Again, 30 to 50 people dead, but a fake disaster in the sense that all these reports about thousands of people dying, thousands of people getting sick, they were fake. They were fake in one sense that had nothing to do with a radiological release. They were true in one sense, and that was the panic and the relocation and the dislocation and the disturbance in people's lives killed several hundred, if not thousands of people. Among them, the induced abortions that were created by, that were wanted by women who were fearing for the health of their baby that they were carrying in their uterus at the time. Okay? Let's compare it to some real disasters. Some of you may be familiar with the term Babi Yar. That is a gorge right on the northwest side of Kiev. It's now surrounded by actually the suburb area there. And this is the picture I took in there in 2014. 30,000 Jews were murdered there in December of 1941 by the Einsatzgruppen, the murderers of the Nazi regime. And by the way, they killed more people than were killed in the concentration camp gas chambers. Real disaster. But Hitler was an amateur. Next to that, this is the real Babi Yar memorial. Let's step back again, back to Babi Yar. There's a fake one. The Soviets, during the Soviet regime, before Ukraine became independent, they put another memorial up there that memorialized everybody, but didn't specifically take out the Jews. And this is the real one. But Stalin was the real, master killer. In the Holodomor, the starvation in Ukraine, the years are up there. He starved about over 4 million people to death. And of course, both Hitler and Stalin were amateurs. We are the real experts. That's on abortion. And by the way, Masters of Death up there in the upper left, that's the title of the book by Richard Rhodes on the Einsatzgruppen, the Nazi killer groups. But this is a sign that I saw in, actually in Odessa. Mamushka, it says on the top there, and that's something like, let me live, I don't know Ukrainian, but on the bottom there it's very clear, stop, abort. And then there's the abortion calendar, or abortion clocks that you can see on the web. And this is the number of abortions on the left in the United States, which is not on there right now, but the cumulative number since Roe v. Wade is about 60 million. And then worldwide, which is over 1.5 billion. And as doctors for disaster preparedness, I think we need to all realize that is the biggest disaster in the US and globally. And this is actually still sort of minimizing the numbers because it's not just the direct abortions, but it's also the ghost abortions. That means the children and grandchildren that could never be born to those who were aborted. They're not in that statistic anywhere. So, again, put things into context. Where are the real disasters and where are the fake ones, or the minimal ones? Fukushima, I'm not going to spend much time on that. This is from one of Helen Caldicott's YouTube presentations. There's no evidence for 3 million dead as a result of Fukushima. As a matter of fact, this is what the Fukushima situation is. They're collecting all the contaminated water rather than releasing it and diluting it in the Pacific. And so they're running out of space, and I'm sorry, they don't really know what to do with it. But the real disaster was the earthquake and the tsunami, the economic losses and the cleanup cost, etc. And by the way, the general cleanup has a goal of cleaning it up for 0.1 rem a year above background radiation levels. So Fukushima is a total never mind from a radiological perspective. Okay? Big disaster in other meanings. This here is a chart that Ted Rockwell put together in his book, and I stole it and modified it a little bit, added a little bit to it. I mentioned earlier the natural background variability on the planet is over at least 2 orders of magnitude. So we have from 0 to 5 rem, or the same thing, 0 to 50 millisievert. And here we have the expansion of the lower segment right here. And there you see that goes up to 0.1 rem. And again, that was the standard above natural that Fukushima cleanup is supposed to go to. Do you see the sense of that? This is the lower end of natural background radiation. And that's where all the other stuff is. And by the way, the biggest contributor to exposure in the United States now of the average US citizen is medical diagnostics. But this is the variability worldwide, and you see the regional areas here. So if you want to clean up to this one, why are you doing that when there's no evidence at all that people who live in these areas up here are subjected to any detrimental effects? This is the old radiation symbol that was stupid enough because everybody is radioactive. Okay? The universe is radioactive. But this is a new radiation symbol, has been enforced for a few years. It basically says if something is radioactive, run away from it. And since you are yourself radioactive, run away from yourself. I mean, it makes absolutely no sense. Oh, and then you have misleading stuff in the National Geographic. This is an article on Chernobyl from 2006, and it shows the fallout plume. Apparently it went up to 400 feet, but then on here it has something entirely different. It says 4.4, 9.3, 2.8, the soil contamination. Now if you add this up, or if you multiply this to exposure per year, and I did it, and hopefully you believe me with that. I am a simple guy, not like our first speaker this morning, so I said, well, 9.3 is too complicated. Let's say it's 10, okay? 10 times 24 hours times 365 days, blah, 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 per year. The final result was 87 rem per year. And that is soil contamination. That means you're going to be exposed to that only if you dig a foxhole and live in that for 365 days. That has nothing to do with a plume height there of 3,500, 3,400 feet or something like that. So if we go back, there is southwest France, 88 millisievert, Ramsar, 700 millisieverts, that beach in Brazil, 790 millisievert. We're at 870 at Chernobyl. Okay? Why do we worry about that? If those people in Ramsar in Iran are not subjected to any negative effects. If we would clean up places today to various standards, and it says here, if I have a radiation level standard of down to 15 millirem, then I have to spend a whole pile of money. If I clean it up to, let's say, 75 millirem, 85, and so on, then I have to clean it. Then I have to spend a lot less money. The Department of Energy, the Nuclear Regulatory Commission, and people who work for them have had pictures like that in their publications for years, but nobody is drawing any consequences from them. And it doesn't make any sense to clean up to these 15 millirem or 0.15 millisievert standards. You saw it in the previous slide. And other experts have said for years, 1995, good gracious, that's over 20 years ago. Radiation standards, they cost $100 million per life year, and we could save so many people by widening rural roads for $120,000 per life. So, my favorite antidote to radiophobia, OCLO. OCLO were natural reactors that operated in Gabon, Africa, about 2.5 billion years ago. This fellow, Paul Kuroda, he actually predicted it. This was the perfect example of scientists coming up with a prediction and then actually finding that, yes, he was correct. Or developing a model or developing a theory and then being proven right. He came from Japan. He was inspired in the 30s by presentations by famous physicists and chemists. He actually worked for a little while in the Japanese nuclear program, which never, fortunately, went anywhere. And then became a US citizen, immigrated, and taught at the University of Arkansas for many years. He was a very humble fellow, as you can see from the quote there on the bottom there. He never thought that he was particularly smart. But in 1956, he published an article that said, well, if we take uranium as it is today, and it's composed of U-238 and U-235, U-238 has a half-life of 4.5 billion years. U-235, the stuff that's used in nuclear power plants and also some nuclear weapons, has a half-life of 700,000 years. If you now calculate back with those half-lives, there must have been a time when there was enough concentration of U-235 in the natural uranium that it was close to or pretty much the same as what we have today, what we use today in fuel elements in nuclear power plants, which would be 3.5%, 4%, something like that. So he did that calculation and said, if the right conditions in a uranium deposit existed 2.5 billion years ago or 3 billion years ago, then it might have been possible that nuclear chain reactions started all by themselves. So he published that paper, something like a 3 or 4 pager, nothing big. And by the way, it was rejected by many journals before he finally got it published. Lo and behold, in 1972, in a uranium mine in Gabon in West Africa, right here, there was such a uranium deposit discovered that had gone critical and had operated for many years nuclear reactors. By the way, for those of you who still remember who Albert Schweitzer was, he had his jungle hospital in Lambarene over here in the same country of Gabon. And I'm showing here a geyser coming up, and here's the reason why. Because these reactors, some of them were only the size of pickup trucks. So lenses of uranium ore, highly enriched uranium ore compared to what we have today. And they operated roughly 2 billion years ago. They ran for about 150 years in 30-minute pulses with 2.5-year dormant periods. So water is a good moderator for nuclear reactions. So the water was percolating through the deposit. The chain reaction started, the reactor heated up. And as it got hot, the water turned to steam, which is a bad moderator, so the reaction cooled down. And after it had cooled down, the liquid came in there again, it started up again, so it was just like Old Faithful, okay? Operated like that. And there's pictures of these reactors. Now, we know this to be true. We have known this to be true since at least 1974. It was published in the Scientific American by George Cohen, who was for decades one of the eminent nuclear chemists for Los Alamos National Laboratory, one of the founders of the Santa Fe Institute, the Santa Fe Opera, a bank, etc., etc., etc. I mean, not just some outside crazy, wingnut. And then in 2005, Alex Meshik at in St. Louis, at the university over there, published another article exactly on the mechanisms of this geyser going on and off for many years. So we know that nuclear reactors were not made by man. By the way, the waste products of that reactor, they stayed right next to the reactors. They didn't migrate all over the countryside and contaminate and mess up lots of countryside. So there were some articles on radioactive groundwater and also on that reactor in the geological literature, and I put across there, this is nuts, because they were saying, you know, Chernobyl proves the fragility of any nuclear facility. It doesn't know such thing. Naturally occurring radioactive particles, we must aggressively address those to ensure a safe water supply. Complete nonsense. Then somebody speculating there on the bottom here that these natural reactors in Oklo, they had toxic byproducts. They must have been environmentally detrimental, biocidal impacts. This was 2 billion years ago. What evidence does he have for any of these statements, and how does this kind of junk pass peer review? And then, of course, we got the anti-nuclear organization. Let's put that up there for fun. Communities against the radioactive environment. Those are the folks that are against everything nuclear and radioactive at Lawrence Livermore in California. If you're opposed to a radioactive environment, you're living in the wrong universe. This is the American Physical Society in a little cartoon book for kids. Enrico Fermi built the first reactor. Nonsense. Nature built the first nuclear reactor. As most of the time, man just imitates nature. Now, has this been realized by the expert community? Of course. We have had talks at meetings of DDP for decades, you know, by Ted Rockwell, T.D. Luckey, Jim Mucker-Hyde, you know, and then all those folks. But it actually has reached the national laboratories too. You see the Sandia logo down there. This is a guy named Mark Miller, who is one, I think, of the co-signers of a petition to the NRC from 2.5, 3 years ago to actually nix the linear no threshold theory and ALARA. And the NRC has been sitting on that ever since. You're talking about a butt print there. You know, last night somebody mentioned butt print instead of footprint. In any case, this is a Sandia health physicist. You know, he's saying, we have known this for 30 years, that there's no scientific basis for all of this stuff. And then he quotes Schopenhauer very appropriately. All truth goes through these stages, ridiculed, opposed, and finally, oh, it's self-evident. And where the heck are we? And there's another publication by him, Radiophobia Kills. You know, at Fukushima, there were evacuation-related deaths. At least one very well documented case of a farmer who hanged himself, and then of course people in ICUs that were transported and they were already borderline fragile. They died as a result of being subjected to the additional stress. So very important point on the bottom, if you're not taking data, you're just making conversation. And let me close with just a couple more slides here. Just to sort of drive home the point that radiation is part of our natural environment. Everything that is happening on this planet, as far as energy is concerned, is driven by radioactive processes. Everything. Fusion is, of course, what runs in the sun, that big fusion reactor up in the sky. And then we have the radioactive decay in the rocks themselves that we have on this planet. And I really, you know, every time I hear a talk like the one by Joe earlier or some other talks about various forms of energy, I always would like to sort of yell at the speaker and say, why don't you go back to the origin and mention, at least in passing, that all energy in its final source or in its original source comes from nuclear. There is no energy except maybe just a little bit of gravity energy that comes from elsewhere. And I like this guy. He was an immigrant from Germany, just like me. There's still a chair named after him at the University of Texas at Austin. But if you start with all the forms of energy that we know, and Joe went through basically most of these energy forms, if you go through them and see where did they originally come from, and you go through gravity and the cosmic rays and stored up supplies and man-induced chain reaction and whatever. Everything, once you trace it to its real origin, it ends up with nuclear or atomic energy. So there is no such thing as alternative energy or green energy or whatever we want to call it. It's all in the final source is nuclear. If we didn't have nuclear, if we didn't have radioactivity, we wouldn't be here, the universe wouldn't be here. And leave you with this last one. Romantic think we're being called stardust because all the elements in the periodic chart of elements outside of hydrogen are made from helium to iron inside stars like our sun, and all the elements above iron have to be made, at least according to our best current knowledge, in supernova explosions. There are no other ways. So all the stuff that we are made of is a result of nuclear processes. We are the byproduct, so we are radioactive waste. And general caution statement that you all have the presentation in your handouts, but it's subject to misinterpretation. Let me just give you quickly the bonus slides. Next to Chernobyl, we visited this place. There's a place called the Duga or woodpecker. This was a big radar installation that was over the horizon radar. That means, and I'm not an expert in electronics or radar or anything like that, so please, I apologize up front if I say nonsense here. They shot this energy up against the ionosphere, and then it bounced back, and it could tell them where and when nuclear missiles were being fired out of their silos in the United States. So one of those installations was there, and it was called woodpecker because to people who listened to shortwave radio, it was a tuck, 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 tuck in the background that they heard during those years that facility was in operation. So there's one right next to Chernobyl, and we went on this narrow road there, and then this is a humongous installation, and I looked on the web. I didn't have my tape measure with me, so I couldn't measure it myself, but it's 50 stories high, 500 meters, half a kilometer wide, and it required something like 10 megawatt. 10 megawatt. So some of the energy from Chernobyl was used to keep this installation running. There, you see, that's how it stands on the landscape there. It's absolutely impressive. And some people actually go there from Western countries and they sneak in there and then they climb this and then they film themselves. Go on YouTube and you can find those things. And then the movie was published about it, The Russian Woodpecker. And that's the last slide here that shows you the Russians had three of those installations, and with their broad fan of coverage, you notice they covered essentially the entire North American continent for a while. So to go back to the beginning, the undertaker of bad ideas, maybe with some of the information that I presented, we can all turn into the midwives of good ideas. Thank you.
Thank you, Mr. Rempe. For the audience, a little perspective on the numbers from his Nuke Alert measuring device, which I also have one of, but I've gone to the trouble of figuring out that based on what some of our previous speakers have published in the past, Dr. Lucky, for example, who wrote a whole book on radiation hormesis, he projected that for optimal health, we should be getting 10 to 20,000 of these millirem units per year.
Yes.
And there's about 10,000 hours in a year. Or actually, it's 8,700 as was reported, but I use 10,000. I'm a rounder offer also. Yeah. At any rate, so the measurements he was giving for optimal health, even flying, it would have been 1,000. So even though you get 30 times as much flying as on the surface of the Earth, that still isn't optimal. Number two, thank you for using the term disinformation. Ian Pachipa, the former chief intelligence operator under Ceausescu in Romania, wrote a whole book on that. Now that's different from misinformation. I characterize misinformation as a press release from the Kremlin or the Pentagon. Disinformation is when it's reported in the New York Times or the Washington Post article as an investigative report by one of their own reporters.
Right. I agree.
Thank you very much for your talk. My name is John Utley. I'm publisher of the American Conservative. We have copies on the desk now out front. I've also written a lot about radiation and the EPA limits. If you just search Utley radiation, U-T-L-E-Y, mainly at reason.com. My question is that the EPA did change its limits for nuclear attack or dirty bombs. I'd started writing about that because if that Boston attack by the terrorism had been a dirty bomb, under EPA they would have said to evacuate half the city. And I own some property in DC. I was afraid they'd evacuate all my tenants. So I, among other reasons, I started writing about this. We got the EPA, myself and Reason and Forbes.com wrote on this, popularizing some of the things you say, to change their limits for nuclear dirty bombs to 50 to 100 rem from 15 millirem. My question is this: have they changed any of their 15 millirem limits for waste disposal or nuclear power plants? They still use, I think, the 15 millirem. And what would be the fraction of cost to build a nuclear plant if they used realistic radiation limits, as opposed to the same for Superfund cleanups, is billions and billions? Is there any movement to use the realistic limits, and what would be the change in cost for constructing plants or cleaning up?
I'm not aware of a change in EPA or NRC regulations. I briefly mentioned the petition in front of the NRC on which it has not acted for now 2.5 years. I don't know what the cost reduction would be, but my understanding is it would be probably or possibly by an order of magnitude. So while there is a lot of talk, there has been no action. In 2012, the American Nuclear Society had a symposium during the annual meeting at their Chicago conference. You can find that on the web on low-level radiation, low background, and Mucker Hyde and Jerry Cutler and all these other people. Their stuff is in there, except nobody uses it as a trigger for action.
I know you're a geologist, but the medical profession has kind of gone nuts about medical diagnostic procedures.
Yeah.
And there are papers that have been produced that project cancers for kids. Yeah. And of course now doctors are being instructed to instruct the parents that radiation is a serious consideration when you're using diagnostic radiology in the emergency department or anywhere else. The problem is that the studies are crap. They project deaths, and they project radiation effects, and they project cancer rates that in fact are not based on a kind of evidentiary analysis at all, but just kind of a gathering of things. So since you're in the business of looking at the radiation policy measures that apply to the population, have you been at least alerted to the problem that we've got a problem in the medical profession with regards to what I would call the precautionary principle to the third power?
Yes, and I believe Bobby Scott, who is another one who talked at several meetings ago to this group, he is really involved with that aspect of it. And of course, also Ed Heiserod, in the introduction to his book, has the example of the lady, I believe, some relative of his or friend of his, who refused to have some diagnostic cancer processes because it was radiological, and then she died, because it wasn't detected early enough. So, yeah, the efforts are out there to make people aware of this irrationality. And every time I go to the dentist, I joke about the lead apron they put on top of me. I'm saying, oh, I'm not getting the good stuff here today. But it doesn't make any difference. So we just need to keep plugging.
You know, one of the interesting things that I see in the hospital setting is radiology technicians talk people out of radiological procedures that I've ordered.
Yeah.
And the way that they do it is nothing more than just scaring them. Are you sure you really want to have an X-ray?
But I think that's mostly caused by, and radiologists are not the only one. We have too many scientists and technicians that only look into their own rut. They don't look left and right. And so they follow the instructions in the book. They're basically cookbook applicants. They apply cookbook prescriptions. They don't think independently. And that's what we need to change, I think. By the way, if anyone is ever interested in that presentation, half PowerPoint will travel. So I think any one of us is willing to do that.
The ChemBio thing that I put together that's going to be on the website has a whole section on radiation illness, so that if you want to sound smart at a cocktail party, you can tell them how many geese or guys would kill somebody.
Just a very minor criticism. I'm a gravitation physicist, and I want to make a positive comment as to gravity as an energy source. In the collapse of a supernova, which, as you correctly remarked, gives the uranium, the core starts about the size of the Earth. In a fraction of a second, it goes down to smaller than New Orleans. You can compute how much gravitational potential energy is released. It's enough to equal the total power output of that supermassive star over its entire lifetime, and also in the outgoing shock wave, generate the neutrons that give the heavier elements uranium. So I would argue that gravity is the energy source in nuclear energy.
I apologize for the shorthand, and I would only add that the gravity then, though, is the trigger for the nuclear fusion reactions that actually create the heavy elements. So, yeah, whether the shock or the collapse, right? Yeah.